Hello everyone. The topic for this video is a arithmetic logic shift unit. Arithmetic logic shift unit is a part of arithmetic logic unit of a computer system. It is a digital circuit that performs arithmetic calculation, logical and shift operations. Instead of having individual registers performing the micro operations directly, computer systems employ a number of storage registers connected to a common operational unit called arithmetic logic unit and abbreviated as ALU. So it means that in our previous videos we have seen that for each and every micro operations different circuits we are implementing. But rather than we'll combine all that micro operation into the one single unit. So that is called arithmetic logic shift unit. So it also contains an arithmetic micro operations. So we are implementing or we are building one circuit that performs arithmetic as well as logical and shift operations. So we are just using one circuit, and based on the input values we are getting the based on the input values the circuit performs arithmetic functions or the logical functions or the shift operations. ALSU consists of arithmetic, logical and shift circuits. In each stage, the circuit can perform 8 arithmetic operations, 16 logical operations and 2 shift operations. So these numbers of operations we can perform by using the arithmetic logic shift unit circuit. So let's understand this with the circuit diagram. So this is the circuit diagram of arithmetic logic shift units. So as you can see the diagram, basically it is a combinational circuit just to perform all the 3 operations which is arithmetic, logic and shift micro operations using the arithmetic circuit, logic circuit and multiplexer. Now here there are 2 inputs AI and BI, and which are assigned as input to both arithmetic and logic circuits. So as you can see in this figure that this AI and BI is already connected to the logical circuit. So this 2 input is given to the logic circuits and this 2 input is also given to the arithmetic circuit. In total there are 4 select lines, but from that there are 2 select lines S0 and S1, which are used to basically select which one of them will work arithmetic or the logic circuit. Then we have a 4x1 multiplexer, and at the output end it chooses the output between the arithmetic or the logic output, and which is done with the help of 2 select lines, which is S2 and S3. There are 2 more inputs here, AI-1 and AI+1, to perform a shift right and shift left micro operations. Also the output carry here Ci+1 of arithmetic circuit must be connected to the input carry Ci of the next stage. So this is basically all for the arithmetic circuit setup. If we want to perform arithmetic operations, so at that time we need AI, BI as an input. We need a carry Ci and select line S1 and S0. Suppose I want to perform logical micro operations, so at that time we need 2 inputs AI and BI, yes, and 2 select line S1 and S0. If you want to perform shift micro operations, at that time the multiplexer requires AI+1 and AI-1 inputs and select line S2 and S3, and based on the inputs it generates the appropriate output. Now let's understand this with this table. So in this table you can see that there is a 4 value for the selection line S0, S1, S2 and S3. There is one field for the carry. Now you can see that here to perform the arithmetic operation we require a carry. So carry value will be from 0 and 1. And to perform the arithmetic operation we do not require the value of S2 and S3, but we require the value of S1 and S0. So here S1 and S0 is 0, 0, carry is 0. At that time it performs the transfer operations. When S1 and S0 is 0 and carry is 1, at that time it performs increment operation. Same as when S1 is 0, S0 is 1 and carry is 1, at that time it perform add with carry operation. So now you can see that in the table till here all the operations are the arithmetic micro operations because it requires a query. After that the carry input is don't care. Why? Because no other operations requires a carry as an input. So from till all the operations are the arithmetic operations. In next, carry input is a don't care. So here in this figure you can see that logic circuit requires S1 S0 input of S1 S0, input of EI BI. So as in this figure you can see that logic circuit does not require a carry as an input. So here the carry is a don't care. So all these operations till here, all these operations is a logic operations. And the last one, and you can see that to perform the shift left and shift right operation we requires only AI minus 1 and AI plus 1. Also only we require only a 2 select line which is S2 and S3, and all other values are don't care. So here S2 and S3 values is given, all other values are don't care. So here these operations are the shift operations. So you can see that in one circuit we can perform arithmetic, logic and shift operations. So this is a combinational circuit, so that is provided by the arithmetic logic shift unit. So that's it. Thank you.